So first off, I'd like to thank Craig and ARC for letting me speak at this event. It's a great opportunity for me. My name is John Davenport. I'm the IT production manager for EnovaPremier. EnovaPremier is a tier 1 automotive manufacturer. We are a tire and wheel assembler. So that means that we put tires on wheels, we inflate them, we test them, and we send them to the OEM. We serve Toyota, Lexus, Hyundai, and GM. We will also be serving Volvo. We are a just-in-time, just-in-sequence manufacturer. That means that our customer is sending over an order, and we are expected to deliver the tire and wheel assemblies in the sequence that they order them, typically within about 2 hours of order placement. So it's a pretty fast-paced environment. There's also the expectation that we can do a data transaction and then almost immediately send a command out to a machine to build that assembly properly. We have some plants where we build batch and we put it in stock, and then we have some plants that are true sequence plants where we are literally getting the order, funneling it into a machine, and building the assembly and putting it on a truck. We run 4 plants. We have 7 lines, and we're about, depending on how you look at it, we're about 2 years into converging and modernizing our plants. We're a pretty traditional, discrete manufacturing environment. We mostly run PLC equipment. We're mostly an Allen Bradley shop. When we got started on this, similar to RJ Reynolds, we had a lot of some custom, some off the shelf. Almost everything was standalone applications and systems. And we've started paring that down and trying to get like a flat architecture and application loadout that we're supporting. So the first question I'd like to answer is why is this of interest to us? Why would we go through all the pain and suffering to do all this work, get everybody on the same page, root out all the old customizations and data silos? Why are we interested in this? And so the real reason that we're interested in this is because the plant comes to us and they say, hey, we have this, we think we have a failure because of this on this piece of equipment. We need you to report when that piece of equipment goes down. We need to classify that downtime. We need to generate a work order in our maintenance system to get somebody to go out and fix it. We need to attach that to a dollar figure. We need to make some kind of decision about investing in fixing that machine. And when we implement that feature, it has to touch the physical automation controller. We have to produce an error code. We have to funnel that into MES and start reporting the downtime. We have to funnel that into the maintenance system and generate a work order. We have to funnel that into a database and start reporting on it, and then tie that to a dollar figure and make a decision about what we do about it. And we need to do about 3 or 4 of those every week or month or day or whatever, so that we're continuing to iteratively improve the way our business operates. And so when we are operating with a lot of different siloed systems that are disconnected and custom and impossible to maintain, every time we want to implement that feature, it's going to take us weeks and thousands of dollars and vendors and coordination to make all that happen. And then when we get done with that, then we have a less supportable and more complex system than we started with. And so after years of operating in that style, then we can afford the customization, we just can't afford to keep them. That's the problem. So the promise of IT/OT convergence for our organization means that we figure out how all of these systems work together very nicely, we get them tightly integrated, and then when it's time to implement a feature, we have a clear path. And we're saying, okay, I have these guys with these skill sets who are going to perform their part of the feature implementation. We know how to get it done and we can make it happen very quickly. So that's our motivation behind why we wanted to do it. So here's how we see, and this goes back to Chris's talk, but the way we see convergence is that it's foundational. If you don't have the lower layers of your pyramid set up correctly, then you're not going to get the higher level benefits out of convergence. So, and we've been going down this path for a while. The lowest layer of this is physical. So this is, how are your servers and equipment racked? How are the wires pulled? How are your switches set up? Where are they placed? What's your subnetting? What's your low-level networking setup? And I don't think anybody's perfect on this. We're certainly not. We're still iterating on some of the lower layers of our pyramid, but we've done a lot of this a lot of this work to enable higher levels of convergence. So the next layer of the pyramid we see is logical. So this is how are your networks set up? How is your virtualization platform set up? If you're using any kind of software-defined networks, how is all that set up? How is your routing set up? The next level of this, once you have all that set up, is you can start looking at, did I hit the down button? The down? Okay. So the next level of this is application resource. So as you start setting up higher level applications like SCADA and MES and reporting and analytics, you have to have the correct application resources set up. So that means centralizing your SQL servers, getting redundancy set up. That means getting your integration layer set up. So what's your OPC layer look like? What's your redundancy? How is that implemented site to site? If you have web servers or other resources that you need available for applications, how are you setting all that up, centralizing it, and making it manageable so that you can support higher level applications that you're going to want and need in your environment to get higher level applications running. The next level is the actual application. So what's your MES? What's your maintenance system? What's your ERP? What's your reporting system? How is all that set up? And then at the top level, as you all have talked about, is analytics. Once you've got all of your foundational stuff set up, you've got your applications in there and running, and they're all producing contextualized data, then you can put an analytics layer on top of that and start looking at everything from a holistic perspective and start making good decisions about how you need to operate your business. So, this is a really fancy list, but this is a list of how our vision for IT, OT convergence is. The idea here is, okay, let's get an idea of everything that we need to do, let's have a vision of it, and then as we move forward on the next step of work, the next piece of work that you're doing for your new line or your new feature or your new implementation, make sure that you're keeping the vision of how things need to be implemented in mind. And so these are the things that we've come up with that are important for us that we believe will lead us to being able to quickly implement features for the plan. So the first one is everything is networked. So we want, unless you have a good and viable reason for keeping some device off the network, we want it on the network. We want it monitored, we want it communicating, we want to be able to get to it. The next one is we want to implement a standard common integration layer. At this time, we would prefer for people not to be ad hoc, plugging things into the network everywhere from different manufacturers that can communicate on different protocols. We'd like that managed. For us, that means that we like to do it in OPC. So if we're going to add another sensor, what we'd really like is for them to get the sensor and then connect it to an input on PLC somewhere, and then to bring that into our OPC server and make that available to our entire portfolio of applications. That's our preference as a company. The next thing is we want all of our applications to be web-based. So I don't want to have to deploy another $700 to $1,000 Dell tower with a fan that I have to warranty and maintain, and somebody on the floor can install malware on accident. I don't want that. What we want is, when we go to deploy a feature, we would like to roll out with the thinnest of thin clients, a Raspberry Pi, a little $80 machine that we can slap on some mounting hardware and connect up to our web-based application. And if the thing fails, we literally have a stack of 5 of them in a closet somewhere, and a maintenance guy can pull one out and throw the old one in the trash and screw the new one in, and we're ready to rock again. And there are other reasons for it, but that's our best one. Next one is, we want all of our applications to leverage standards-based web APIs. The reason for that is that we want to implement complex feature sets that span multiple applications. And the best way to do that integration is through a software integration. So that's another thing that we focused on. If we're going to buy your application and put it into our environment, we need it to have a solid API, we want it to be documented, and we want to be able to write our own integrations. The next one, which I hope is obvious at this point, we want all of our production critical assets to be virtualized. We want 0 machines on the floor that can be run over by a forklift and shut down the line. So if it's production critical, we are going to find it and we are going to migrate it onto a VM and get it off the floor as soon as possible. This also has the advantage of leveraging our immense backup and redundancy and reliability features that we have built into our virtual environment. So this is a very important thing to us. And these two actually tie in because a lot of these production critical assets that we found on the floor would be sitting there with a OPC server and a database server and a custom application, which is bad from a reliability perspective on our side. We like to leverage service-oriented architectures wherever possible. So that means that all of these application resources that we've identified, our database, our integration layer, our web server, everything else that we can sort of centralize into a single purpose VM that sits in our environment is an advantage for us because then we know what the components of our application are and we know what to go and fix when something breaks down. We like to use inexpensive, easily deployed Zero clients wherever possible. So like I said, Raspberry Pi, little Intel NUC boxes, and it's something that's really cheap, that's really easy to deploy and hard to break and maintains very little configuration locally. That's a great advantage for us. We also believe in exposing all customizations. So we don't want custom code in a thick client sitting on a computer somewhere that we cannot maintain. We can afford to get it, but we can't afford to keep it. 2 years down the line, when the developer who wrote that for the vendor leaves and we have to make the support call to figure out how this application works and get it running back on the floor, that's a nightmare. So our goal here is, we go back, all applications leverage standards-based web APIs so that we can make those API calls, we can write up a Python script or something like that that's going to make those API calls for us. We can expose it and it's maintainable by the entire team. This also goes back to another principle that I didn't put on the list, but we seek to implement 90% of our feature set in off-the-shelf applications and to implement 10% of our feature set in exposed customizations. So, and that's part of vendor identification, is finding somebody who can do most of what we need without having to get a bunch of unsupportable custom code or having to write a bunch of our own customizations. And the last one is a training and political issue, which is let's coordinate, document, communicate, and train in specific technical terms with all of the teams within the organization. Because what we get into is this conversation where somebody says, oh, well, you have the data off from the PLC to the PC and then profit. And that doesn't work for us. That's an unproductive discussion that won't get us, it won't move us anywhere. It won't get us supporting anything. It won't get us implementing anything. It doesn't work for us anymore. So with that vision in mind, we're implementing a new line for one of our customers, and we've taken all of that and we're using that. So what we've done is we're using MES from Funnel Cloud. They've been a great vendor for us because they conform to all those standards. They have an entirely web-based application. They are focused on discrete manufacturers. They are an OPC compliant product. They run on OPC UA. They've provided us with a virtual appliance that we've been able to plug right into our virtual environment. They provide standards-based web APIs that allow us to make REST calls and put in data or get out JSON data structures and write it into PLC tags. They've also provided us with a REST API wrapper for our ERP system that allows us to make the same level of like integrations back to our ERP system. and they address 90% of our feature set. They've been a great company to work with. Most of the customizations that we've exposed have been with either with Data Hub or just directly in Python code that we run on the same server. We run a very specific, an industry-specific ERP, and we're also connected back to ClickSense for most of our reporting. And we have this same, server set with centralized application resources and service-oriented architectures and Raspberry Pis on the floor. And we're in the middle of that implementation, but it's been going very well, and I think we'll spin up the best plant in our portfolio with that. So thank you for your time.